There are two common methods of testing a fiber optic link. One involves pass-through testing, which gives you attenuation values for the whole link. The other method involves an OTDR, or optical time domain reflectometer if you prefer. The OTDR, when in use, is paired with a test fiber box, and of course the test fiber box has to be of the same fiber as your system you'll be testing. In our case here, we'll be testing two reels of fiber connected through a splice point. For a single mode system, the fiber needs to be at least 200 meters. My box here contains 300 meters of fiber. A typical OTDR screen has a y-axis and an x-axis. The x-axis measures distance and the y-axis measures attenuation and reflection in units of decibels. In addition, you have an ability to select the type of system you're testing. In this case, it's a single mode system, and the wavelengths under which to test the system. You can also select the length of the system and also the signal power, which is selected by choosing various pulse widths. And also you can select the acquisition time. It is always a good idea to test your test fiber box before connecting it to the system, which we will do now. The length of my test fiber box is about 300 meters, as can be seen here. And we are now ready to connect it to the rest of the system. Always clean your connectors before mating them. We can now shoot a trace across the whole system. After the preset acquisition time has expired, I can see that my trace is about 13 kilometers long. And most of the events are concentrated around the beginning, and I will zoom in there. There are two events, number 2 and number 3. The first event is where the test fiber box is plugged into the OTDR. There are no values, either reflection or attenuation, that can be garnered from this particular spot, and that's why we use the test fiber box. This area is called the dead zone. The test fiber box allows you to overcome the dead zone with this length of fiber here so that you can see your first connector pair that is connected to your system. That connector pair has a value, and if I look at the event table, I can see that the value is about 0.305 or dB, which is okay, and the reflection is about negative 53.7, all good values. The third event is the splice connecting the two reels, and that value is 0.172 of a dB. Again, not too bad. We prefer them to be about a 0.1. The rest of the length is the third reel, and then the end of the system, a high reflective peak again, and then drops down into noise. The reason for the reflective peaks is the discontinuity that exists between a connector pair. There is a minute gap between the connectors. A splice has no discontinuity, and that's why it only has attenuation associated with it. Let's see what a cam splice may look like. After replacing the splice point with a cam splice, the trace looks a little bit different. The event number 3, where the splice was, is now slightly reflective. If you look at the event table, there is a loss or attenuation associated with it of 1.58 and a reflective value of minus 71 dB. The cam splice is better than a connector pair in that there is index matching gel between the two fiber ends, therefore mitigating the reflection. Other information available from the event table are things like the span length and the location of the end of your system. OTDRs have so many other features, but that's it for now. If you have any other questions, please give us a call or send us an email at cablesystems@corning.com. And remember, Corning Cable Systems recommends getting trained in fiber optic installation. We offer a series of classes, of course, and we thank you.